exclusively I will be solving the problems from this model question paper. How will I find the resultant intensity at C? Right angle triangle, I can define sin theta there. So it does not have a unit, it is just the quality of the resonance curve. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. I'm here today performing this session to solve the model question paper 6. Exclusively, I will be solving the problems from this model question paper. The first one, 2 point charges, 4 microcoulomb and 2 microcoulomb. There are 2 point charges. One has magnitude 4 microcoulomb and the other has magnitude 2 microcoulomb. And they are placed at the vertices A and B of a right-angled triangle. So very clearly, the given triangle is a right-angled triangle. Here he says, B is the right angle. So we will construct the triangle now. So according to the question, B is the right angle. So this is A and this is C. Now AB is √3 centimeter. So this distance AB is √3 into 10 power minus 2 meter. BC is 1 meter and AC is 2 meter or 2 centimeter all throughout. So into 10 power minus 2 into 10 power minus 2. Calculate the magnitude and direction of the resultant electric intensity at C. Very interesting. Now not at the right angle, not at the point B. You are asked to calculate the magnitude and direction of the electric intensity at the point C. Now, what is the charge placed at A? 4 microcoulomb. Charge placed at B? 2 microcoulomb. Charge placed at C? I am testing the electric intensity at C. So, we have a UPC. As we did earlier, how will I find the intensity? First, I will find the intensity at C due to the charge at B. I call that E1, and E1 acts away from the UPC. So here we have E1 is equal to 1 by 4 pi epsilon naught QB by R square, general expression for intensity. So this is equal to 9 into 10 power 9, 2 microcoulomb charge, 2 into 10 power minus 6, separated by a distance of 1 centimeter, or 1 into 10 power minus 2 whole square. And on simplification, E1 turns out to be 18 into 10 power 7 Newton per coulomb. This calculation is exclusively for y'all. Next, I will calculate intensity at C due to the charge at A, E2, which again acts away from the UPC. So, here again, so E2 is equal to 9 into 10 power 9, 4 into 10 power minus 6, and what is the distance? 2 into 10 power minus 2 meter. So 2 into 10 power minus 2 whole square. And again, on simplification, this is 9 into 10 power 7 Newton per coulomb. So I have got E1. I have got E2. How will I find the resultant intensity at C? Again, the same parallelogram law. So this is E, this is theta, and this is alpha. How will I find theta? Right angle triangle. I can define sin theta there. So sin theta is, according to the triangle, AB by AC, opposite by hypotenuse. So AB by AC. So sin theta is root 3 into 10 power minus 2, 2 into 10 power minus 2. Sin theta is root 3 by 2, which means theta is 60 degrees. So now theta is known. E1 and E2 are known. How do I find the resultant intensity? E is root of E1 square plus E2 square plus 2E1 E2 cos theta. Substitute 18 into 10 power 7 whole square, 7 into 9 into 10 power 7 whole square plus 2. Substitute for E1, substitute for E2, cos 60, and on simplification, this turns out to be 23 into 10 power 7 Newton per Coulomb. You have to be thorough with the simplifications. Umpty number of problems we have worked out here. Now we have to calculate the direction alpha. So alpha is tan inverse E2 sin theta E1 plus E2 cos theta, and on simplification alpha turns out to be nearly 19 degrees 6 minutes. A quite genuine problem. Step by step you solve, you will arrive at the answers. Next one, quite interesting problem again. 3 equal resistors. 3 equal resistors, which means 3 resistors which has the same value of resistance. So 3 equal resistors are connected in series. Across a source of negligible internal resistance, together dissipate 10 watts of power. So very clearly he says 3 equal resistors. 3 resistors which have the same resistance. When they are connected in series, they give out 10 watt power. What would be the power dissipated? How much of power is given out if the resistors are connected in parallel across the same source? Andre, there are 3 resistors which are initially connected in series. Now, generally, what is the expression for power in terms of resistance and voltage? Yakandre EMF same ant kelidare. So P is V square by R. Here R is nothing but RS, and I call P1 to be the power when the resistors are connected in series. So this is 10 V square divided by 3 identical resistors. So please to remember, when 3 identical resistors are connected in series, the effective resistance is N into R. N is the number of resistors, R resistance value. So this becomes 3 times R. This is equation 1. Now the same 3 resistors are connected in parallel. In this case, P2 is V square by RP. So if you observe here, since the problem says they have the same EMF, the value of V remains same. And when they are connected in parallel, so Rp becomes equal to R by N, or P2 is V square R by 3, or P2 is 3V square by R. This is equation 2. I want the value of P2. So divide 10 divided by P2 is V square by 3R into R by 3V square. V square gets cancelled. R gets cancelled. So what is P2 equal to? Now we have 3V square. So this is 9. So P2 is 90 watts. See, just knowing the expression for power, series identical resistors, resistors in parallel, I have got the required answer. Next one. Again, very simple. Calculate the resonant frequency of a series LCR AC circuit with an inductance 4 Henry, capacitance 64 microfarad and resistance 20 ohms. I should also find the Q value. Q value andre quality factor of the circuit. Now, the inductance is given to be 4 Henry. Capacitance is given to be 64 into 10 power minus 6 farad. Resistance is 20 ohms. Now first, I will calculate the resonant frequency, which now I keep in terms of omega naught, because with that I can calculate quality factor, and I know omega naught is 1 by root LC. So this is 1 divided by root 4 into the value of C, 64 into 10 power minus 6. This on simplification is 62.5. Look at the unit, radian per second, because I have considered omega naught. Now with this, I will find the quality factor or the Q value of the circuit. So the Q value is equal to omega naught L divided by R. So this is 62.5 into 4 divided by resistance, which is 20. Again, just simplify. This is 12.5. And remember, it's a number. It's a factor. So it does not have a unit. It is just the quality of the resonance curve. Again, a simple one. Calculate the angle of minimum deviation produced by an equilateral prism of refractive index 1.65. Now going to the expression, we know refractive index of a prism is sin A plus D divided by 2 divided by sin A by 2. What is A? Angle of the prism. Capital D is the angle of minimum deviation which has to be calculated. Or rearranging this, sin A plus D by 2 is n into sin A divided by 2. So sin of A plus D by 2, refractive index is 1.65 into sin A by 2. A is 60 degrees. 60 by 2 is 30. So this is half. So 0.825. So this is A plus D by 2 is sin inverse 0.825. And on calculation, D turns out to be nearly 11 degrees. Sorry, so it turns out to be 51 degrees, 2 minutes. Again, a question paper is solved. Hope you practice these problems, become thorough. In my next session, I start working out numericals from the previous annual question papers. Until then, have a nice time. Thank you.